FreeInit, bridging initialization gap in video diffusion models. Though diffusion-based video generation has witnessed rapid progress, the inference results of existing models still exhibit unsatisfactory temporal consistency and unnatural dynamics. In this paper, we delve deep into the noise initialization of video diffusion models and discover an implicit training-inference gap that attributes to the unsatisfactory inference quality. Our key findings are: 1. The spatial temporal frequency distribution of the initial latent at inference is intrinsically different from that for training, and 2. The denoising process is significantly influenced by the low-frequency components of the initial noise. Motivated by these observations, we propose a concise yet effective inference sampling strategy, FreeInit, which significantly improves temporal consistency of videos generated by diffusion models. Through iteratively refining the spatial temporal low-frequency components of the initial latent during inference, FreeInit is able to compensate the initialization gap between training and inference, thus effectively improving the subject appearance and temporal consistency of generation results. Extensive experiments demonstrate that FreeInit consistently enhances the generation results of various text-to-video generation models without additional training. FreeControl, training free spatial control of any text-to-image diffusion model with any condition. Recent approaches such as ControlNet offer users fine-grained spatial control over text-to-image (T2I) diffusion models. However, auxiliary modules have to be trained for each type of spatial condition, model architecture and checkpoint, putting them at odds with the diverse intents and preferences a human designer would like to convey to the AI models during the content creation process. In this work, we present FreeControl, a training-free approach for controllable T2Y generation that supports multiple conditions, architectures, and checkpoints simultaneously. FreeControl designs structure guidance to facilitate the structure alignment with a guidance image, and appearance guidance to enable the appearance sharing between images generated using the same seed. Extensive qualitative and quantitative experiments demonstrate the superior performance of FreeControl across a variety of pre-trained T2I models. In particular, FreeControl facilitates convenient training. FreeControl over many different architectures and checkpoints allows the challenging input conditions on which most of the existing training-free methods fail, and achieves competitive synthesis quality with training-based approaches. DiffMorpher, unleashing the capability of diffusion models for image morphing. Diffusion models have achieved remarkable image generation quality, surpassing previous generative models. However, a notable limitation of diffusion models, in comparison to GANs, is their difficulty in smoothly interpolating between two image samples due to their highly unstructured latent space. Such a smooth interpolation is intriguing, as it naturally serves as a solution for the image morphing task with many applications. In this work, we present DiffMorpher, the first approach enabling smooth and natural image interpolation using diffusion models. Our key idea is to capture the semantics of the two images by fitting two LoRa's, latent optimal transport-based registration models, to them respectively, and interpolate between both the LoRa parameters and the latent noises to ensure a smooth semantic transition, where correspondence automatically emerges without the need for annotation. In addition, we propose an attention interpolation and injection technique and a new sampling schedule to further enhance the smoothness between consecutive images. Extensive experiments demonstrate that DiffMorpher achieves starkly better image morphing effects than previous methods across a variety of object categories, bridging a critical functional gap that distinguished diffusion models from GANs. Rethinking compression, reduced order modeling of latent features in large language models. Due to the substantial scale of large language models, LLMs, the direct application of conventional compression methodologies proves impractical. The computational demands associated with even minimal gradient updates present challenges, particularly on consumer-grade hardware. This paper introduces an innovative approach for the parametric and practical compression of LLMs, based on reduced order modeling, which entails low-rank decomposition within the feature space and reparameterization in the weight space. Notably, this compression technique operates in a layer-wise manner, obviating the need for a GPU device and enabling the compression of billion-scale models within stringent constraints of both memory and time. Our method represents a significant advancement in model compression by leveraging matrix decomposition, demonstrating superior efficacy compared to the prevailing state-of-the-art structured pruning method. Alignment for honesty. Recent research has made significant strides in applying alignment techniques to enhance the helpfulness and harmlessness of large language models, LLMs, in accordance with human intentions. In this paper, we argue for the importance of alignment for honesty, ensuring that LLMs proactively refuse to answer questions when they lack knowledge, while still not being overly conservative. However, a pivotal aspect of alignment for honesty involves discerning the limits of an LLM's knowledge, which is far from straightforward. This challenge demands comprehensive solutions in terms of metric development, benchmark creation, and training methodologies. In this paper, we address these challenges by first establishing a precise problem definition and defining honesty, inspired by the Analects of Confucius. This serves as a cornerstone for developing metrics that effectively measure an LLM's honesty by quantifying its progress post-alignment. Furthermore, we introduce a flexible training framework which is further instantiated by several efficient fine-tuning techniques that emphasize honesty without sacrificing performance on other tasks. Our extensive experiments reveal that these aligned models show a marked increase in honesty, as indicated by our proposed metrics. We open source a wealth of resources to facilitate future research at Project's website, including honesty-aligned models, training and evaluation datasets for honesty alignment, concept glossary, as well as all relevant source code. CCM, adding conditional controls to text-to-image consistency models. Consistency models, CMs, have showed a promise in creating visual content efficiently and with high quality. However, the way to add new conditional controls to the pre-trained CMs has not been explored. In this technical report, we consider alternative strategies for adding ControlNet-like conditional control to CMs and present three significant findings. 1. ControlNet trained for diffusion models, DMs, can be directly applied to CMs for high-level semantic controls, but struggles with low-level detail and realism control. 2. CMs serve as an independent class of generative models, based on which ControlNet can be trained from scratch using consistency training proposed by Song et al. 3. A lightweight adapter can be jointly optimized under multiple conditions through consistency training, allowing for the swift transfer of DMs-based ControlNet to CMs. We study these three solutions across various conditional controls, including edge, depth, human pose, low-resolution image, and masked image with text-to-image latent consistency models. VILA, on pre-training for visual language models. Visual language models, VLMs, rapidly progressed with the recent success of large language models. There have been growing efforts on visual instruction tuning to extend the LLM with visual inputs, but lacks an in-depth study of the visual language pre-training process, where the model learns to perform joint modeling on both modalities. In this work, we examine the design options for VLM pre-training by augmenting LLM towards VLM through step-by-step controllable comparisons. We introduce three main findings. 1. Freezing LLMs during pre-training can achieve decent zero-shot performance but lack in-context learning capability, which requires unfreezing the LLM. 2. Interleaved pre-training data is beneficial, whereas image-text pairs alone are not optimal. 3. Reblending text-only instruction data to image-text data during instruction fine-tuning not only remedies the degradation of text-only tasks, but also boosts VLM task accuracy. With an enhanced pre-training recipe, we build VILA, a visual language model family that consistently outperforms the state-of-the-art models, for example Llama 1.5, across main benchmarks without bells and whistles. Multimodal pre-training also helps unveil appealing properties of VILA, including multi-image reasoning, enhanced in-context learning, and better world knowledge. Honeybee, Locality-enhanced Projector for Multimodal LLM. In multimodal large language models, LLMs, a visual projector plays a crucial role in bridging pre-trained vision encoders with LLMs, enabling profound visual understanding while harnessing the LLM's robust capabilities. Despite the importance of the visual projector, it has been relatively less explored. In this study, we first identify two essential projector properties. Flexibility in managing the number of visual tokens, crucial for MLM's overall efficiency, and 2, preservation of local context from visual features, vital for spatial understanding. Based on these findings, we propose a novel projector design that is both flexible and locality-enhanced, effectively satisfying the two desirable properties. Additionally, we present comprehensive strategies to effectively utilize multiple and multifaceted instruction datasets. Through extensive experiments, we examine the impact of individual design choices. Finally, our proposed LLM Honeybee remarkably outperforms previous state-of-the-art methods across various benchmarks, including MME, MMBench, SeedBench, and LavaBench, achieving significantly higher efficiency. Code and models are available at the project's website. Interfacing foundation models embeddings. We present Find, a generalized interface for aligning foundation models embeddings. As shown in teaser figure, a lightweight transformer interface without tuning any foundation model weights is enough for a unified image, segmentation, and dataset-level retrieval understanding. The proposed interface has the following favorable attributes. 1. Generalizable. It applies to various tasks spanning retrieval, segmentation, etc., under the same architecture and weights. 2. Prototypable. Different tasks are able to be implemented through prototyping attention masks and embedding types. 3. Extendable. The proposed interface is adaptive to new tasks and new models. 4. Interleavable. With the benefit of multitask multimodal training, the proposed interface creates an interleaved shared embedding space. In light of the interleaved embedding space, we introduce the Find Bench, which introduces new training and evaluation annotations to the COCO dataset for interleave segmentation and retrieval. Our approach achieves state-of-the-art performance on Find Bench and competitive performance on standard retrieval and segmentation settings. The training, evaluation, and demo code, as well as the dataset, have been released at the project's website. Fast training of diffusion transformer with extreme masking for 3D point clouds generation. Diffusion transformers have recently shown remarkable effectiveness in generating high-quality 3D point clouds. However, training voxel-based diffusion models for high-resolution 3D voxels remains prohibitively expensive due to the cubic complexity of attention operators, which arises from the additional dimension of voxels. Motivated by the inherent redundancy of 3D compared to 2D, we propose Fast-3D, a novel Masked-Diffusion transformer tailored for efficient 3D point cloud generation, which greatly reduces training costs. Specifically, we draw inspiration from masked autoencoders to dynamically operate the denoising process on masked voxelized point clouds. We also propose a novel voxel-aware masking strategy to adaptively aggregate background-foreground information from voxelized point clouds. Our method achieves state-of-the-art performance with an extreme masking ratio of nearly 99%. Moreover, to improve multi-category 3D generation, we introduce Mixture of Expert (MOE) in 3D diffusion model. Each category can learn a distinct diffusion path with different experts, relieving gradient conflict. Experimental results on the ShapeNet dataset demonstrate that our method achieves state-of-the-art high fidelity and diverse 3D point cloud generation performance. Our FastDit 3D improves one nearest neighbor accuracy and coverage metrics when generating 128 resolution voxel point clouds, using only 6.5% of the original training cost. How well does GPT-4V ision adapt to distribution shifts? A preliminary investigation. In machine learning, generalization against distribution shifts, where deployment conditions diverge from the training scenarios, is crucial, particularly in fields like climate modeling, biomedicine, and autonomous driving. The emergence of foundation models, distinguished by their extensive pre-training and task versatility, has led to an increased interest in their adaptability to distribution shifts. GPT-4V ision acts as the most advanced publicly accessible multimodal foundation model, with extensive applications across various domains, including anomaly detection, video understanding, image generation, and medical diagnosis. However, its robustness against data distributions remains largely underexplored. Addressing this gap, this study rigorously evaluates GPT-4V's adaptability and generalization capabilities in dynamic environments, benchmarking against prominent models like CLIP and Llama. We delve into GPT-4V's zero-shot generalization across 13 diverse datasets, spanning natural, medical, and molecular domains. We further investigate its adaptability to controlled data perturbations and examine the efficacy of in-context learning as a tool to enhance its adaptation. Our findings delineate GPT-4V's capability boundaries in distribution shifts, shedding light on its strengths and limitations across various scenarios. Importantly, this investigation contributes to our understanding of how AI foundation models generalize to distribution shifts, offering pivotal insights into their adaptability and robustness. Code is publicly available at the project's website. Steering Llama 2 via Contrastive Activation Edition. We introduce Contrastive Activation Edition (CAA), an innovative method for steering language models by modifying activations during their forward passes. CAA computes steering vectors by averaging the difference in residual stream activations between pairs of positive and negative examples of a particular behavior, such as factual versus hallucinatory responses. During inference, these steering vectors are added at all token positions after the user's prompt with either a positive or negative coefficient, allowing precise control over the degree of the targeted behavior. We evaluate CAA's effectiveness on Llama 2 chat using both multiple-choice behavioral question datasets and open-ended generation tasks. We demonstrate that CAA significantly alters model behavior, outperforms traditional methods like fine-tuning and few-shot prompting, and minimally reduces capabilities. Moreover, by employing various activation space interpretation methods, we gain deeper insights into CAA's mechanisms. CAA both accurately steers model outputs and also sheds light on how high-level concepts are represented in large language models, LLMs. COLMAP-Free 3D Gaussian splatting. While neural rendering has led to impressive advances in scene reconstruction and novel view synthesis, it relies heavily on accurately pre-computed camera poses. To relax this constraint, multiple efforts have been made to train neural radiance fields, NRFs, without pre-processed camera poses. However, the implicit representations of NRFs provide extra challenges to optimize the 3D structure and camera poses at the same time. On the other hand, the recently proposed 3D Gaussian splatting provides new opportunities given its explicit point cloud representations. This paper leverages both the explicit geometric representation and the continuity of the input video stream to perform novel view synthesis without any SFM pre-processing. We process the input frames in a sequential manner and progressively grow the 3D Gaussians set by taking one input frame at a time, without the need to pre-compute the camera poses. Our method significantly improves over previous approaches in view synthesis and camera pose estimation under large motion changes. Our project page is project's website. PEEKABOO, interactive video generation via Masked-Diffusion. Recently, there has been a lot of progress in text-to-video generation, with state-of-the-art models being capable of generating high-quality, realistic videos. However, these models lack the capability for users to interactively control and generate videos, which can potentially unlock new areas of application. As a first step towards this goal, we tackle the problem of endowing diffusion-based video generation models with interactive spatio-temporal control over their output. To this end, we take inspiration from the recent advances in segmentation literature to propose a novel spatio-temporal masked attention module, PEEKABOO. This module is a training-free, no-inference overhead addition to off-the-shelf video generation models, which enables spatio-temporal control. We also propose an evaluation benchmark for the interactive video generation task. Through extensive qualitative and quantitative evaluation, we establish that PEEKABOO enables control video generation and even obtains a gain of up to 3.8 times in mean intersection over union, MIU, over baseline models. Llama Guard, LLM-based input-output safeguard for human-AI conversations. We introduce Llama Guard, an LLM-based input-output safeguard model geared towards human-AI conversation use cases. Our model incorporates a safety risk taxonomy, a valuable tool for categorizing a specific set of safety risks found in LLM prompts, that is, prompt classification. This taxonomy is also instrumental in classifying the responses generated by LLMs to these prompts, a process we refer to as response classification. For the purpose of both prompt and response classification, we have meticulously gathered a dataset of high quality. Llama Guard, a Llama 27B model that is instruction-tuned on our collected dataset, albeit low in volume, demonstrates strong performance on existing benchmarks, such as the OpenAI Moderation Evaluation dataset and Toxic Chat, where its performance matches or exceeds that of currently available content moderation tools. Llama Guard functions as a language model, carrying out multi-class classification and generating binary decision scores. Furthermore, the instruction fine-tuning of Llama Guard allows for the customization of tasks and the adaptation of output formats. This feature enhances the model's capabilities, such as enabling the adjustment of taxonomy categories to align with specific use cases, and facilitating zero-shot or few-shot prompting with diverse taxonomies at the input. We are making Llama Guard model weights available, and we encourage researchers to further develop and adapt them to meet the evolving needs of the community for AI safety. I want it that way, enabling interactive decision support, using large language models and constraint programming. A critical factor in the success of decision support systems is the accurate modeling of user preferences. Psychology research has demonstrated that users often develop their preferences during the elicitation process, highlighting the pivotal role of system-user interaction in developing personalized systems. This paper introduces a novel approach, combining large language models, LLMs, with constraint programming to facilitate interactive decision support. We study this hybrid framework through the lens of meeting scheduling, a time-consuming daily activity faced by a multitude of information workers. We conduct 3 studies to evaluate the novel framework, including a diary study, an =64, to characterize contextual scheduling preferences, a quantitative evaluation of the system's performance, and a user study, n=10, with a prototype system. Our work highlights the potential for a hybrid LLM and optimization approach for iterative preference elicitation and design considerations for building systems that support human-system collaborative decision-making processes.